Hey guys, today we talk about how to tackle complex systems with modular development. And we talk about what modular development actually is, where you would use it and where you would not use it. And my guest currently works as software architect over at ASML, André Borgonovo. Don't forget to like and subscribe on YouTube and follow us on your favorite podcast platform. Enjoy.
Welcome to Beyond Coding, a dive into the world of successful people in IT. From your sponsors, Zebia, creating digital leaders. Here's your host, Patrick Akil.
Hey, André.
Hey, hello.
How's it going?
I'm doing fine, thank you.
Good,
How are you
man.
doing?
I'm great, thank you. Very nice to have you here.
Thanks for having me.
We've already been chatting a lot before the show.
Yeah.
So I can't wait to kick off the topic. So I brought you on here to talk about how to tackle complex systems, and more specifically with modular development. So as a first question, can you lay out why you're passionate about kind of these or handling these complex systems in the first place?
Yeah, sure. So modular development is kind of a very common thing if you think about it, of course. If you talk to any software architect, he will tell, I want to have a modular system in the end.
Yeah.
Either be that a monolithic system with modules or a microservices architecture with modules.
Yeah.
But I think sometimes it's quite tricky to actually end up with a good modular system. So defining modules that are highly cohesive and at the same time are loosely coupled between each other is quite a challenge. I got very interested in that topic because I think it's just the fundamentals of software architecture that many times we don't get right. So that's where my interest in.
Nice. And you already covered on kind of what modular development is, but what is it specifically? Like working with modules, what does that mean?
Yeah, so when you get a system, some systems are so simple that you can think, okay, I can just make it. But sometimes you get a very complex system and dividing that into small pieces make it more simple. So you assign certain responsibilities to those components or modules.
Yeah.
And then you can assign maybe that to a specific team or to a person to work upon. And that gives you the capability of handling the complex problems of a system in a more comprehensive way. So modular development will tell you that you can define well-defined modules, which will provide certain interfaces to other modules. And each module will talk to very strict interfaces. So knowing exactly what is expected from each other. Yeah. And with that, you can have system functionalities that can provide the value that the system needs to provide.
Interesting. So I know monoliths, right, which is like a big application. It's kind of intertwined in a lot of things. And on the other end of the spectrum, you have microservices, which have kind of low or maybe high complexity, but low weight of code, right? Small, but they are complex because there's probably a lot of them. Depends on how you do that. But they handle their own complexity by themselves. They're very isolated in that way. Where's kind of modular development in this axis then? Yeah,
I think you can have modular development in both cases. And we could say that microservices is an attempt to make a modular system. So you could consider that each microservices is a module. Yeah. So in one end, that's also a modular development. What happens is that when you go for microservices, you bring lots of complexity to the infrastructure. Yeah. So microservices gives you lots of advantages. Like, for example, you can have independent deployment. Yeah. You can deploy your own service, update that in a production environment without impacting your complete system. So you can keep up with your uptime in a very good way. Monolithic, of course, you can have a monolithic system in a modular way. So there's a very a bad view or bad take on monolithic systems in the sense that they are always bad. And I don't think that's the case. Simon Brown is a software architect who lives, I think, close to England. He talks about modular monoliths. Yeah. And the idea there is that you can, of course, have a monolithic application that runs in a single process. Yeah. So whenever you want to deploy, you pretty much takes the system down, maybe. But on the other hand, you can organize and scale that in terms of development and in terms of tackling the complexity of a certain domain by breaking that monolith into separate modules. And I think that's an option that many teams can take when they don't need the advantages that a microservices architecture would bring, like independent deployment, which is one of the main principles of microservices, or one of the main advantages of going with microservices. Yeah. So I think that's something that should be really considered by most of the teams when they don't need those kind of capabilities.
Yeah. You're right about monoliths, that they already have a bad rap, but I think it's changing in kind of a general sense. And it might have to do with kind of a modular monolith setup then. But if I'm looking at software development, right, there's the things I can change, which is probably the way that the code is written or the code that you write, and the things that are a bit harder to change, right? It's similar to buying a house, right? I can't really change the layout of the house that I have or the apartment, but I can change the kitchen, for example, or I can change the bedroom, or I can break down a wall here and there. But a lot of the things, even location, is not something I can change if I actually have bought the house. If you're making a system and you want to make it into a modular kind of setup, is that then something you start with, which means that you can't really fundamentally change it anymore? Or is that something you can evolve into later on?
That's a very interesting question. Of course, the ideal world is that you start with that.
Yeah.
One of the approaches, for example, suggested, I think, in one of the Martin Fowler's blog, I'm not sure if it was written by himself or by one of his collaborators, is that you can go with a monolithic, a modular monolithic first approach. Let's say if you think you will need to create such a complex system that you need to end up with microservices.
Yeah.
You can start with a modular monolithic application in the beginning, where you clearly define the interfaces between each part, and then you can evolve that as you see your requirements growing or your scale growing into small microservices. So that will help you on that path. So it's an approach called monolith first.
Yeah.
On the other hand, when you have a monolithic application which is very entangled, so as I mentioned, module is something that most of the architects will consider in the first place when they are developing their application for the first place in the first moment.
Yeah.
But it's hard to maintain that over time. If they have an many entangled modules, of course, refactoring is the way. So you need to consider again, go back into the drawing table and look at what are the responsibilities within your system and try to define especially the interfaces between those modules, where you start decoupling the implementation of one module to the implementation of the other. So you rely on clear contracts between the modules, and that would be the way to get back into shape when you get into a big ball of mud, as they call it in a monolithic application.
I really like that you have the option to start with kind of a modular monolith, and the mons in this episode are going to be off the charts, but you start with that. And if you see that the complexity is reaching that point that it makes more sense to cut off a module and make it its own separate entity, right? Might start off with a one-off microservice in that case. You have the option to do so because you've already set and defined those boundaries. But then how do you define the boundaries between a module? What makes a module separate from a different module, for example? Why are they not the same module?
That's interesting. That's quite challenging. You really need to look into the domain. So that's where a software architect can help. He needs to understand how the organization works, what are the requirements of the application, and there are some patterns that you can find. There's a quite nice website called Microservices.io where you can find some of those patterns. So you can try to define that by functionality, for example, if you have, and I would say that if you are going for a modular monolith, really try to look into the microservices patterns. So microservices, they have to handle and define, how do I define a microservices? How big it is? How small should it be? So those questions can help you understanding how you can plan your own module, how you were going to define that. And I think one rule of thumb, of course, is what function that module should have within the system and what problem will that solve. Software architecture, I really like this definition. Software architecture is about components, responsibilities, and relations. So trying to identify the components of your system, how they interconnect to each other, and their responsibilities, of course. and then try to apply requirements on top of that, that will give you a clear direction whether your components are going being split in the right way, or if you need to split them further, or maybe if two components are too coupled together. So that's more or less the way to go.
Yeah, and it goes hand in hand. The reason why we kicked off kind of this topic is to solve complex problems, right? And do you think this approach, I mean, this is just my assumption, but because it has the option to evolve as complexity grows, it might be a good kind of approach to handle those complex systems? But what is it also adding towards to next to that?
I think it might help you. So if you split your system with clear responsibilities, so you have clear modules and clear responsibilities. As you grow, there are several ways that you can scale. One is the number of users might grow. So you need to be able to be performant to reply to those requests.
Yeah.
The other way, of course, is that you might have teams growing because you need to have much more features that need to be implemented for the system. In that sense, if you have a modular development, you can also assign certain teams to take care of a certain module, as you would do for microservices, for example. And then in that sense, you make it clear that the interactions with the other teams or the contracts or the interfaces are well established upfront and like approved by each other on the expectations, requirements, and so on for the implementation to continue. So giving these modules a clear boundaries will help you also with the definitions of your own teams. That's one possibility.
Yeah, that it makes sense to me that a modular can reflect the domain a business is in, right? Or even a subdomain or a microdomain, depends on your definitions. Because then you can also cut it loose and give that entity that autonomy and responsibility to a separate team then.
Exactly.
Yeah, and I really like that it has the option to evolve there, because you're never going to start off there, because you're not necessarily sure where your domains lie. I think in the beginning, you might have an idea, but it's I think better if you have it battle tested and then you cut it off, or you refactor and then you cut it off, because then you have a better grasp of what the reality actually is in that way.
That's correct. And I think a key aspect of that is really on the interfaces, or the APIs, as you would call it. When you have a module talking to another one, or a team talking to another one, you have an interaction between two parts of a company, or maybe two modules of two software modules. There are expectations from one to the other, and if you clearly define those interfaces, you can make the expectations clear, and you can also try to make those interfaces well encapsulated. So preventing that you have coupling where you don't need to have. So the mantra for modular development is really highly cohesive. So you have a module that does what needs to do. And at the same time, loosely coupled. So how you achieve loosely coupling, defining your interfaces in a good way. So be keen on defining APIs that are minimal, in the sense that they only request information they need and they only provide information they need. And then that opens up the possibility to evolve your system and add more information only at the moment when it's required.
Exactly. If they were not that loosely coupled, then you could never give that autonomy to a different team.
That's right.
You would always need to align with both teams to get stuff done because of the couple there, the coupling there. Yeah, I really like that. But then, so you grow as an organization, right? You think you start with a complex system, you start with your modular monolithic approach, and then you're like, okay, we think the complexity has reached a certain point that we need to kind of cut it off. When, or even how do you make that decision?
I think the point there is the following. So it's not necessarily complexity. So you can have a really big code base. For example, you can imagine Windows. Nowadays, it's developed in a single Git repository. It's the biggest repository in the world, by the way. And they have that everything in a single repository. So you can develop really huge, complex systems in kind of a monolithic way. The question there is, I think, the following. So if you need to split those that monolith in different processes, so that's the first question that you would take. And then you have several reasons to do that. For example, if you want to start if you need more memory space for some reason. Nowadays with 64 bits applications, you pretty much don't need that, but that would be one reason. If you want to decouple, for example, dependencies. So for example, you have a monolith that depends on third party.
Yeah.
Well, if you have a monolithic application that depends on a third party, you need to consider that all the modules within that monolith will depend on the same version of that third party. Otherwise, you need to find a certain way to handle and load those assemblies in a different way.
Yeah.
Well, load those assemblies. My background is C#, so sorry for that.
No worries.
But you can make the parallel with other languages, of course, and frameworks.
Yeah.
And then if you want to decouple and have the capability of depending on different versions of those third party, then you might think of, okay, I need to host this process in this module in a different process.
Yeah.
So that's kind of a first step. At the moment that you find out that your application or your solution should also be capable of being deployed independently, for example, and I think that's really one of the first key points, then you really need to consider to go for more to something more like a microservices architecture, where you not only separate in two processes, but you also create a pipeline that allows you to publish those separately.
Yeah, but then when would you make that decision? So the third-party packages, I can make sense of that. Two different versions might clash, and you don't want to juggle that, so you can cut part of your application based on that. But when are you like, oh, it makes more sense to deploy this part separately from its own? Does it have to do with how often the code changes?
I think it has to do with how much of a business capability you want to deliver frequently. Yeah. So if you need to keep your application up and running all the time, for example, you might want to be able to deploy that without taking the application down. So if you are in a web application environment, for example, microservices might be the best option for you. Yeah. So you're capable of introducing a new feature in the shopping cart of your e-commerce, for example, without taking down your application. So those are business drivers that can be an answer for that. But you should consider, of course, that sometimes you have challenges that you will find in a Windows desktop application or Linux or whatever that might be different than a web application.
Yeah. Interesting, because the business drivers, let's say you cut off part of your domain because you want to deliver value faster within that domain, that could also be incentivized then to get a separate team up and running specifically for that domain.
Exactly.
Yeah. So an organization can structure kind of their business needs also within the software and kind of vice versa. Because you split it up, it makes sense to have a separate team for that as well, and not be within you're not going to have a team of 50 people working on the same thing if it can't be operated kind of autonomously in a way.
Yeah.
Right. Interesting.
I think one of the most interesting learnings that happened in the last decade or so was around the Conway's law. Okay. So this law that talks about how the software really reflects how the communication paths within your organization are handled. So how each department talks to each other, how people solve their own problems, and the software in the end ends up reflecting that. And I think there's a learning within the software community of also trying to use that that aspect of software development in a maneuver to make the other way around. So if you have a business that really needs to have a software in a certain way, why not organize your own structure of your enterprise in the way that offers the best business capabilities? Yeah. And most likely it could be that the software is organized in that way as well. Yeah. So there's a name for this maneuver. I'm sorry, I don't remember. The inverse Conway maneuver, if I'm not mistaken. Yeah. So to really make use of this law, in the own benefits of the organization.
Yeah, that makes sense, because software is always supporting business needs in a certain way, right? And if it makes sense from a software perspective to set up some different entities because you want more business value, then maybe on an organizational level, it also makes sense to have that same cut on your business people. I use business people in kind of the broadest sense of the word. Yeah. But if you want to deliver value within a certain business domain, makes sense to both split up software as well as the people that are going to drive that domain from a business perspective then.
Exactly. It's the feedback between business and software happening in both ways.
Exactly. It just synergizes better that way. At least it I think so conceptually. Yeah, that it makes sense that way. But as you grow, the teams will be more autonomous and you might have more teams, right? If your business needs grows or your business drivers grow, you can cut off your application in certain ways. But then your team structures are growing as well, basically. How do those teams then still interoperate if they need something from each other? Because they will need something at some point, right? You're still running on the same backbone in a way.
That's true. So you might need to find ways to, you might need to take some decisions. So if you have a big team working in a single module, for example, you can decide to assign specific components to certain teams. So within the module, of course, you can divide that as well, like following a system of systems pattern, making it small components that talk to each other and that solve the problem of that module. At a certain point, it might be that you want to take one of those components and make that a module for yourself. Let's say, promote that component as a module. Those decisions, it depends on each situation, of course.
Yeah, that makes sense.
What I can tell, again, is that interfaces are the key there. So if you have a module that you know that it is complex and you might want to define that, you might want to divide that into different components, think about the interfaces of those components. So how each component will talk to each other in terms of APIs. So it should be clean, like minimal. And you should consider, of course, patterns like inversion of control, dependency inversion, and so on and so forth. Yeah.
What happens when that kind of interface definition is not as clean as you've defined it?
Then it becomes harder to divide those components. So if you face a situation, as you mentioned, where you need to promote one component as a different module, you will have a trouble to do that. So you might need to go through a whole cycle of refactoring before you can do that.
Yeah. And then do you think, because from an architectural point of view, this is kind of the picture on the painting that you want to have, right? But the developers are usually the people that fill that in. Do you think developers more and more need to kind of get a grasp of what the architecture is as well as when they're developing?
Certainly. I think I don't believe in software architecture where the developers are not involved. I think they should be involved from the beginning, and there should never be a gap between whatever is drawn on the table and whatever is in the code. I know that's challenging. I know that's kind of a vision, but that's what we always should aim for.
Yeah, exactly. I mean, it's a lot of responsibilities that developers get nowadays, even with the cloud. It's more and more operational responsibility, even financial, because what do you spend in the cloud? And are you spending it the right way? Are you turning off the lights when you go home? And now also kind of the architectural point of view. Do you think kind of the role of a software architect is always going to be still its separate entity down the line? Or is that going to be merged into kind of software development as well? It's kind of a trait that you do.
I think a bit of both. So I believe it's nice to have software architects in teams because, of course, it depends on the maturity of the team, how the organization works. But mostly software architects can help with giving focus to certain quality attributes that sometimes the development team will not take care of by themselves. So having someone really giving focus to those attributes is really important. On the other hand, the tasks of a software architect can totally be done by software developers. So that's the thing is, of course, as a team, you should make sure that the tasks are done. And not necessarily you need to have someone assigned as a software architect. In some scenarios, I believe it's good to have someone assigned as a software architect because then that person will take responsibility for that and really know that this is under his responsibility. So he needs to act on those tasks. So it's as the more mature the team is, I have the feeling the less you have the need for a single person to be the software architect.
It's good that accountability is still within one or a group of people within the team. But as you've laid it out, I think it makes sense because also on a security perspective, that can be one or multiple people within the team, but you want to kind of have the same mental model when it comes to what you're doing. Same holds true with testing and testability, right? The kind of paradigm you choose and the standards you've set should be shared across the team members. And I guess with architecture, it's exactly the same thing. I don't know why that would be any different. So it's
yeah,
good that
perfect.
You made me realize that. Yeah.
Yeah. And otherwise you end up with these gaps, right? Where you have a very nice picture on the wall about the software, how the architecture should look like.
Yeah.
But then in the end, the developers know that's totally not true. And I'm just implementing this code here to solve this problem. And that should not be the case. I think you should really aim to close that gap and have those worlds talking together.
Yeah.
And then, of course, when you were talking about the overall software architecture, you can solve things in a much easier way. And everybody's kind of talking the same language in the team as well. Yeah. I might talk again about Simon Brown. He created something called the C4 diagrams.
Okay.
And the C4 diagrams just provides 4 levels of diagrams. So a system context diagram, a system diagram, a container diagram, and a system diagram, container diagram, component diagram, and class diagram.
Yeah.
When I'm using that, I really have the feeling that it's useful to put namespaces in that. So namespaces for C#, what would be for Go or for Java?
What do you mean by namespaces?
Namespaces, I think in Java would be packages.
Yeah, and Go would be packages as well.
But packages, okay. So when you put packages on diagrams, for example, you make the connection directly onto your source code.
Yeah.
So you close that gap a little bit. So when a software developer is looking at the diagram, it's not a logical thing anymore. It really reflects something that is in the code base.
Yeah.
So I think that's a way where you can prevent that from happening.
Yeah, you don't want to... there shouldn't be a gap in what you're drawing and what's actually in the code base, right? It should reflect the truth, and the truth is how it's deployed in the code.
Correct. Yeah.
Yeah. But moving back to then modular software development, I'm still wondering, as your teams grow, if there's going to be any other growth pains, right? Let's say your interfaces are well defined, so your teams don't have that much attachment to other teams, but still the people and the company kind of grows, right? And the complexity doesn't necessarily grow, but the amount of value you want to deliver grows, which is why your teams also grow and operate autonomously. What are some of the kind of growth pains that come with that you've seen?
Well, I think one of the benefits of having modular development. So imagine when we're talking mostly about monoliths, we're talking about a single repository, a Git repository, for example. When you put things to be defined and developed in their own modules, what happens is that you prevent lots of merge conflicts because people are working or teams are working specifically on their own modules and talking to each other in a very clear contract. I think the pain is pretty much on using a single repository. So sometimes that might be challenging. When your repository grows too big, the checkouts might be a bit slow. You might end up having too many files there. Cloning times might be slow as well. Building the whole thing might be slow. Testing. So I think that's one of the key pain points that you should be careful about. Again, there are lots of examples that you can find around. I said the Windows development. The .NET development is quite a nice use case as well on GitHub. So you can imagine .NET framework is quite a big framework. And Microsoft did recently a movement from, I don't know how many repositories, that they tried to minimize the number of repositories into a few. So they have around 5 repositories nowadays that contain the complete framework. And that was a movement for them to simplify their environment. So sometimes when you go into too much of a split in your application, it becomes complex to manage as well. So if you can have that in a smaller scale, even though you have a very big team working on that, it's doable. You just need to plan that and of course, look for the pain points and work on them.
Exactly. But also from a technology perspective, I was listening to a talk from Patrick Akil, and he laid out kind of a contrast of Google versus Amazon, in which Google has kind of a standardized technology set. I'm hoping I don't get the two confused up, but let's assume Google has that standardized technology set. It's easy from a team perspective to switch to another team, right? The domain might be different, but the tech stack and kind of the tools that you're operating with are kind of standardized across the whole company there. And on the Amazon kind of side of things, it's more experimental, right? And different teams might use different tool sets, different languages, different frameworks to get their business value up and running in that way, right? So you have two paradigms in which the technology is very similar. It's very easy to shift through teams. And on the other hand, it's harder to shift through teams, but you have the more, you can leverage the tools maybe better because you can experiment more and see if a tool can deliver the value that you're accomplishing for in a better way. What's kind of your take on kind of those two viewpoints?
I'm going to take another viewpoint then.
Go ahead.
Yeah, Spotify. I have written about them. So I think all companies are dealing with this kind of problems.
Yeah.
And Spotify, they had in principle from the beginning freedom for each team to develop using whatever language they wanted, whatever tool they wanted. And what they decided to do is the following. They thought, okay, it's getting a bit complicated. So because there's lots of complexity also when you decide to start something with a new language, you need to learn about it, or maybe coach your team to deal with that. You need to fill out the infrastructure needed for that. You need to prepare the server for that. So there's quite some complexity around that. Yeah. Spotify decided to create what they called golden paths. So we have certain options. These are predefined by the company, so to say, company-wise. And if you go for that direction, I know I can tell you're going to have support from the company. You already have everything arranged. You have tutorials or whatever, patterns, guidelines. So you can follow this golden path, which is known and supported by the company. If you want to take another approach, you're totally free to do so. And if you have really a good reason to do that, please go ahead. Yeah. But if you want to go in the more easy path, to have the least resistance in development and to be capable of focusing only on the business value that you want to add, these are the golden paths that you can select within the company. So I found that to be a very interesting approach. Yeah, very interesting, because the golden paths already allow you to, well, you're probably going to have first movers anyway, right? And kind of pave the way, but that can be a golden path. And because you've had first movers, they can educate the people that are going to tread the same pathway, right? Otherwise, if there's no knowledge sharing in that way, everyone would be a first mover, and then it doesn't matter which technology you pick and if you've done it before or not. Exactly. So I really like the options but then you still have the experimental option, right? If you really think the technology that you're going to use, you can leverage in increasing that business value as you should intend, then you still have the option to go experimental. Exactly. It's right down the middle. Exactly. Yeah. That's what I like it. Yeah. Yeah. And then of course, as you mentioned, switching from one team that uses Golden Path A to another team that also uses Golden Path A might be much easier. Exactly. Yeah. Except then the cross thing, you can never, I think, account for that. Otherwise, you would have to be standardized across the road. Yeah. Even within kind of, let's say, a module is going to be separated, but a different tool or a different technology can be leveraged better to increase business value in that way. It still needs to be maintainable. You already mentioned a lot of things that need to go into incorporating kind of a new technology. But what are some of the decisions that then someone needs to make? Let's say we want to use a new language, but it hasn't been battle tested yet. Is that something you can do within an experiment? And then even when you do that in an experiment, a proof of concept that it can scale, is it then a good idea to scale? Or would you rather have one of the other either languages or tool sets that have been a bit more battle tested? Like, when does a tool go from experimentation phase or however you want to name it to kind of a more production-ready state? That's a challenging question, of course. I want to bring to the table something that I think it's important, and it's a discussion that was very broad, and I think in Brazil. Yeah, they were questioning there that in IT or in software development in general, it's quite a new market or quite a new knowledge that started in the world, so to say, and we have lots of people that don't have the background in a university. You can make a different university course and then join software later on, and you can still be a fantastic software developers. Some of the software developers, which are the best I know, they don't have any computing science background. Yeah. Nevertheless, it's quite a critical profession.
Yeah.
Nowadays, everything runs on software, right? You have hospitals, you have airplanes, you have tons of things that are critically rely on software on critical things.
Yeah.
So we should be careful not to be amateur professionals, as they call it in Brazil, and we should be keen on the importance of software development in the companies and in the corporations. Of course, this depends on the type of business you were working on.
Yeah.
But okay, taking that into consideration, whenever you were making a decision for some language or for some framework that you were going to use, you need to consider the trade-offs. We were thinking and talking about that before.
Yeah.
And trade-offs in the sense like, okay, how much benefit I gain from this language or this new framework that I'm going to use versus what are the risks involved.
Yeah.
And sometimes it's not only software risk, but also company-wise risks. Like, will I find people in the market to work on this new language that I'm trying to bring? Will that really benefit the company? Will that give an advantage for the company because this is a thing that's becoming very popular and I'm going to attract tons of talents?
Yeah.
So I think, I'm sorry to give that answer, but as a software architect, I might say it depends.
Yeah. No, as you've laid it out, I don't think there's a golden answer there, right?
Yeah.
Some business value allows for more experimentation than others.
Exactly.
Right. And it depends on the context that you're going to use it in, and also into the degree that you can actually use it.
I think a simple advice would be, if you are taking a decision to go with a new language, share that with another one and decide together with a group instead of trying to decide for yourself. I think that's a key thing that you can take. So talking with other people, talking maybe with your manager to decide together. So probably more, if you're not deciding by yourself, but with a group, probably other views will come into play, and then you can have a more concrete and a better decision. Yeah,
that makes sense. I like leaning on the team for that aspect, right? And weighing out the decisions of each individual in a way. Because you as an individual can only get benefit from it, right?
Correct.
It's not only your opinion that matters, it's the people that you're doing it with. And that collective opinion is what should matter the most, and it's probably also going to be the best one. Because as you mentioned, a lot of software engineers have kind of their own background and their own kind of golden path in which they came here. Maybe golden path is not the right way, but just their own kind of journey. So they take that experience and that perspective with them. And it differs from person to person, which is why that end result, if you use the team and leverage their opinion in that way, is going to be better in the end, right? That's why we look for diversity within companies or even within teams, because we've researched that diverse groups perform better and give either more creative solutions or just more effective than groups which are not that diverse.
Oh, that's really fantastic. Yeah. When you have the chance to work in those very diverse groups, you might end up having lots of fights.
Yeah.
But those will be really useful for you to grow, to learn different views, to learn different perspectives, and to collaborate as well with your own perspective. So, yeah, I think that's the best place to be, really, when you have a diverse team with different views.
Yeah.
And if you find out a way to do commitments between each other, to find agreements and disagreements, and to lay out the trade-offs, I think those teams are really capable of getting the best out of it.
Yeah, absolutely. I really subscribe to that mindset. Yeah. As one final question I had, I'm wondering what your take is on this, because we already touched upon hiring, right? And that you want to work on the technology that you can also hire for. But developers want to also work on the technology that they can then go to a different company for. And it's kind of a circle that you can't get out of, right? If you introduce a new technology, but you can't hire for it, then why introduce the new technology? A corporation is kind of at risk then, that they're implementing something, and if the team leaves or if there's a knowledge gap there, it can't be run in production anymore. They can't really maintain it, right? And on the other hand, you want your developers to be able to experiment with new technologies and bring that to the market as well, even though you might not be able to hire for it. So how do we, as organizations, how do we prevent from just standardization across the whole board in what's out there, just for the sake of hiring? How do we still allow for that kind of experimentation and bringing in the right people with the right mindset who can still do that thing eventually?
That's quite challenging.
Yeah.
I think big companies are probably dealing with that all the time.
Yeah.
Because of course, software is becoming more and more important for any company.
Yeah.
You want to have your software developers happy with what they are doing,
Yeah.
and not only happy, but also not having to deal with all the complexity that software development brings. You want to have them being capable of adding value to your business. I don't think I have a clear answer for that. I think it will always be an attempt, and especially what I think companies should take on that is that if they know there's a certain technology that a CTO, for example, knows will be the next technology, and it will be very differential for their operations, and so it will really make a difference. I think what companies can do and maybe should do is to be able to coach and train people. So there's sometimes a gap in the number of professionals that we can hire, but we can also find ways to train junior developers into those languages. And that's something I think it's kind of a social thing that companies can start working on, and really not only thinking to find people that are ready on the market, but also trying to train people that are just coming out of the university, for example.
Yeah, I love that, because if you have the right mindset, you should be able to make use of that and learn a new skill, right? That's what we do as software engineers, or a lot of people in tech just do that on a regular basis in learning a new application. Could be a new language, could be a new framework, could be a new platform, but be able to let go of what you know and learn something else.
Exactly.
Right? And if a company's open for that, it makes them probably more agile in the way that they're approaching things, right? The way they can pick up and let go of things, because their people have that mindset, right? That's in their DNA that they hire for.
Yeah, exactly. And I must say that most of the software, the junior software developers that I work with, they were just fantastic. They are full of energy, super willing to learn and to try to do good things. So there's a big chance that you create a fantastic team when you get some of those people that have the necessary support to work within the team. My own experience is that most of the times it's quite interesting to have those people within the team. So that awesome combination again on diversity.
Bring it back. Awesome, man. I want to thank you for coming on, André.
Thank you for having me.
I learned a lot actually.
Me too.
It makes sense because I didn't start from a software background, but a lot of the things that modular monolith, as you've laid it out, I have seen it before, right? I maybe couldn't name it at the time, but now it makes sense in why our approach was that way, or why our architecture was that way, also with kind of that future evolvement in mind, that it was always an option. So thank you a lot, man.
I appreciate.
And let's chat again soon sometime.
Yeah, thank you.
Cool. André Borgonovo, everyone.
Beyond Coding. From your sponsors, Zebia, creating digital leaders.